Hi guys, so this is homework 15 solutions for discrete math class. So this week our reading was based on the expected values and the variance, but the majority part of the homework problems that I assigned has to do with the expected value and also the probability and the counting, which we covered in the previous weeks. So let's go ahead and do some of these problems. Okay, so the first question is, what is the expected number of heads that come up when a fair coin is flipped 5 times? So pretty easily I can guess that the answer to this is going to be 2.5 because the biggest thing is that it's a fair coin, which means that the coin would have the probability of 1/2 of getting the heads. And so 1/2 times the number of times, which is 5. So 1/2 times 5 would be 2.5. We can more aggressively kind of show this by utilizing our counting and probability methods, just like I think some of the problems that has shown in our textbook. So let's actually go ahead and do that. So when n is 0, so I'm talking when n is the number of heads. So in a case where we have no heads, so we're essentially just talking about a single case, the probability of getting 5 tails. So this is going to be 1 over 2 to the power of 5. Okay, so and let's talk about when n is 1. What about the case where we have 1 head? Then this is going to be the probability of, head and 4 tails. This is possible. And also, this is possible, and so on. So the total number is 2 to the power of 5, and we're going to have 5 cases where the h is located at different locations out of the 5 spaces. So this is what we have, and so on. I think you guys can go ahead and finish up with the counting process. When n is 2, then actually let's go ahead and use our previous homework, last week's knowledge. So when n is 2, this is going to be, looks like 1. 5 choose 2. Oh, and this is essentially just 5 choose 1. So this is going to be 5 choose 2, 2 to the power of 5. And so on. When n equals to 3, then this would be 5 choose 3, 2 to the power of 5. So essentially, when we get to all of those with the counting, and you guys can also utilize the binomial table, 1, 2, 1. I'm sure you guys have learned this or seen this in high school math class, and you just add these two numbers. So 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4 and 1, and you keep going. 1 plus 4 is 5. That's 10, 10, 5, 1. So if you notice, we're utilizing that row, which is going to be 1 over 32 times 0, because n is 0, okay, plus 5 over 32 times 1, because our n is 1, plus, and the numerator is going to be these numbers. So it's going to be 10 over 32 times 2, plus another 10 over 32 times, this is when the n value is going to be 3, plus the next number is 5, so 5 over 32 times 4, plus the last number is 1, so 1 over 32 times 5. And if you calculate this, it should give you the number of 2.5. So 2 ways. This was pretty simple enough problem that you guys can use your intuitive sense to get to the right answer. But if the problem is no longer so intuitive, then you guys can actually count or use the probability to get to the right answer. Okay, so on that note, let's go on to problem 2. what is the expected number of heads that come up when the fair coin is flipped 10 times? So instead of just going over the answer to this, I will leave this question up to you guys. It's extremely similar to number 1. You guys can either use your intuitive sense or actually show the math behind to get to the answer for number 2. Alright, so let's go on to the next problem, number 4. A coin is biased so that the probability of a head comes up when it is flipped to 0 is 0.6. What is the expected number of heads that come out when it is flipped 10 times? Okay. So for this problem, probably the linearity of expectation could be used, which you should have read about on our textbook. So our textbook does a good job explaining what the linearity of expectation is and also gives some problems. If you understood what that concept is, so linearity of expectation, if you know what this is, then this problem is pretty simple. You can just apply 10 times 0.6, which is 6. So instead of doing the math, which was what we did in the previous problem, we can just directly apply this concept and say that, the expected number of heads that will come up would be 6. And which makes sense because what this means of 0.6 is that it's biased. It's not a regular fair coin. If you flip it, there is a higher probability that the head will come up than tail. Alright, so let's go ahead and move on to the next problem, which is number 6. So 6 is, what is the expected value when a $1 lottery ticket is bought in which the purchaser wins exactly 10 million if the ticket contains the 6 winning numbers chosen from the set, and the purchaser wins nothing otherwise. Okay. Alright, so in this case, we can take a look at the two things. We can first calculate the probability of winning, and also, well, let's think about that first, okay? So let's calculate the probability of win. There are 50 choose 6 possible ways to get the ticket. And out of this, there is only one winning. So it should be actually 1 over this one. So this is a total number of possibilities. And there should be only one out of all of these. That's going to be the winning ticket. So therefore, write it here. So probability of, do P of winning is going to be 1 over 50 choose 6. Okay, and in this case, the amount of money that you would have won, so if that's the case, then that should be 10 million minus 1, because you spent that $1 of purchasing the ticket. Okay, now let's take a look at the other case. If it's not winning, then you're losing. Okay, so what's the probability of losing? Well, that's just going to be the 1 minus the winning case, which is 50 choose 6. And this would be just $1, because that's how much the lottery ticket costs. Okay, so this would be 10 million minus 1. Let's see if I can count. That's going to be this much over, well, let's think about, we have to subtract these two, so let's go that first. So this is going to be that times P of winning. Now we're trying to calculate the expected value. Minus $1 times this. Okay, so $1 times probability of losing. So this would be, count again, so that's going to be 9 Okay, that over, what was the probability of winning? That was 50 choose 6. Okay, minus, now this is going to be 1 times this, which is just going to be 1 minus 1 over 50 choose 6. We can use some distribution rule that this minus sign will be distributed. So that's going to get us, after some algebra, we're going to get minus and minus becomes positive, so we have that plus 1, which will get us back to 10 million. 50 choose 6, should be not, and 50 choose 6, and we still have this negative 1, so we're going to write that down. Okay, so that's it. I'll leave you guys to this. Whatever that you guys find here, that would be the answer to this problem. So whatever you find here, that would be the expected value that the purchaser wins the ticket